It's my honor to present this talk. Tonight, I would like to talk some experience for building the open source ecosystem for the new LoongArch ISA. First, I will make a brief introduction of the LoongArch ISA. Then I will talk about its ecosystem evolution. Then comes some measures to accelerate the building of this ecosystem and some lessons learned. The background, why there's LoongArch, why LoongArch will be designed. And many years ago, maybe around at least 15 years ago, people debate on this topic for a long time. So which ISA should Chinese processors take? We have several choices. The first one is that we can use some existing commercial ISAs. Its strength is that we can utilize the existing ecosystem. This is a very good and big benefit. And but its weakness is that we all know most commercial instruction set, including x86 and ARM, is closed or half closed, and the other one has limited ecosystem. The second choice is that we can bring out a new one. But the strength is that we have the full design freedom. We can abandon some history burdens. But the weakness is we have to pay the cost to set up a new ecosystem. At that time, nobody can exactly tell how hard it is, how big the cost will be. And the next one is that at that time, no suitable open instruction set available, but now we have RISC-V. The strength is will be open, but at that time, RISC-V is not yet available. But at the time LoongArch is bring up, RISC-V has been existed for some years, but it's not chosen because we think it's not yet quite ready for desktop and servers, and we have some policy concerns at that time. For example, the foundation has not moved to Swiss now at that time. So LoongArch, in brief, it's a new instruction set with compatibility in mind. The main idea is that since every choice is since not perfect, then can we use some technical to be both independent and compatible? To be independent, we designed from scratch. This allowed us to discuss some node historical burdens and to absorb features useful for modern workloads. And we use the processor-aided high-performance binary translation to legally utilize the mainstream ecosystems. And for LoongArch, current focus is on desktop and servers. In fact, that's another reason RISC-V is not chosen, because RISC-V up to today should be most strong at IoT fields. And this instruction set is designed by Zhang. And it will be fully open soon. talk about the binary translation. This is the target of the for risk instructions, because the semantical gap is not so big. So we expect to very high efficient translation. For example, from MIPS to LoongArch, we have designed some prototypes, the translators that can translate almost at native speed. And for the target will be 90%. And for x86 translations, the efficiency will be targeted at 80%. Now it's close to 70%. We're still improving it. LoongArch, let me talk about its features. It's a risk style instruction set. We have 64 bits, LoongArch 64, and we also have 32 bits. And it's a modular design. We have a base instruction set and plus several extensions. A lot of instruction slot is reserved for future further extensions. If anyone feel interested, you can visit this site to get get to some more documents on the details. I just briefly introduce it. And next, the evolution of its ecosystems. It can be divided into 4 stages roughly. The first stage is to set up the minimal system. In my memory, the timing might not be very exact. Maybe I am too old to be exact. In year 2019, we spent around 6 months to set up the minimal system, including QEMU-based instruction set simulator and the whole tool chain, and minimal rootfs. It roughly consisted of hundreds of open source packages. Then the stage 2 is take another 6 months. At this stage, we put most used softwares, including big ones like Chrome browser and Java developer kit, Java virtual machine, and Golang and KVM for cloud. All these components are developed in simulator. So we use a lot of machine to parallel building things. And a lot of iteration is done between the instruction set itself, the application binary interface, the RTL design, and the applications. Then comes the stage 3. In this stage, we build a full liveness distribution. It's another 6 months. The first implementation of LoongArch is Longshan 38500. This processor is 2.5 gigahertz 4-core processor. It's much faster than the simulator. So the ecosystem evolution is significantly speed up. So we start from Debian 10. It has in total has more than 29,000 packages. And we at this stage we have more than 25,000 packets ported to LoongArch. Among these 25,000, with around 3,000 of them has architecture dependent code. We roughly statics is that about 400,000 lines of new code, so all kinds of architecture support. And plus another 4,000 kilometer lines of security related patches. At this stage, we go through a full rebuild due to major application binary interface change. And the last stage is from 2020 to now. We get a mature ecosystem mature enough to support many commercial usages. Now we have five GPU models for LoongArch. Its current status I will show you from this 5 aspects. First, we do a lot of specification and standards. I mean, adding support of LoongArch into these standards. For example, the ABI system-wide ABI, it has a processor-related part, and for the firmware, the BIOS, LoongArch support is officially appeared in version 2.10. And for ACPI standard, version 6.5 officially support LoongArch. And for the others, I will not go through everyone. And this standard is very important for the ecosystem. It's the basic. For example, without standard support from ACPI, the BIOS would not accept LoongArch support, and without some file format numbers, the toolchain community will not accept the LoongArch support patches. So today we have got a lot of open source operating systems with the LoongArch support. First, LoongArch itself has the community version, which is based on Debian 10. And this open community OS from Ali, it has support LoongArch. OpenEuler, just that Mr. Xiong has talked about OpenEuler. The OpenEuler is working on LoongArch support. Official support is expected at next release. And for the Debian upstream, the work is started, and maybe next version we will see official support. We have a lot of some not official personal supported OSs, and much more small OSs, including the teaching OS such as MIT SV6, and we have SEL4 microkernel OS, etc. So the most major open source software components support LoongArch now. Here is a whole picture, including all big ones for cloud, Docker, KVM, OpenStack, Kubernetes, Ceph, and big data, and database and middleware, and browsers, and so on. From early this year, LoongArch has put a lot of effort in upstream all their work. So up to now, we have many core components upstreamed. For example, for Linux kernel, initial support for LoongArch started from version 5.19, and full support will be in version 6.1. And for the firmware, the code is merged October the 14th. And for QMU simulator, LoongArch support is start from the version 7.1. And for the whole tool chain is now support LoongArch. And for Golang, for .NET, for LLVM, for Chromium, Firefox, and a lot of media and math libraries has all LoongArch accelerated implemented, and numerous other small ones. So is it enough? No. For Linux distributions, it seems most of the packages already supported. We know 26 out of the 29 has been ported. But what's left, the remaining 3,000, it's mainly some, for example, the Pandoc, we didn't finish the Pandoc porting, and some packages is related to Pandoc. And we have some Java related to one, and we have some Python related to one. This is all can be contributed to some hidden sub-ecosystems. For example, Python has more than 200,000 packages. We all know that we can install the many Python packages to facilitate our development. But for x86, this 200,000 is all available. But nowadays, only 300 is available for LoongArch. So this is a big sub ecosystem that we need to work on. The situation is very similar for others. For example, Java, if you use Maven, you can download a lot of packages. Many of them has architecture dependent. This even surprised me. Initially, I thought that Java is a cross-platform. Its package should be or the architecture independent, but no, many packages is right in has some architecture dependent paths. And another big sub ecosystem is come from cloud. For example, the Docker. We has a huge repository for Docker. Docker Hub has more than 3 million images for x86, and it has roughly 200,000 for ARM, but 300 for LoongArch now. So this is the whole picture today. Most important major one is okay now, but we have still a lot to go. Next, I will talk about some measures we used to accelerate the evolution of LoongArch ecosystem. The first one should be binary translation. With the help of the binary translator, we call it LoongArch. It's a short name for LoongArch Architecture Translator for x86. LoongArch can support most x86 Linux applications. Many Windows x86 applications. and almost all printers. This is the creative usage. Then we use the binary translator to reuse the Windows printer drivers, so we can support almost all printers. In fact, half of them is not supported or not well supported, only the normal Linux platform. And another one is we have a customized browser that support IE ActiveX plugins. At least in China, there's many deployed product systems depends on this kind of plugins. So if you are not able to support that, then your machine will not be able to use these systems. And we can use the binary translator to use the x86 Docker images transparently. So the 3 million the packages is no longer a problem. And we are also seeking ways to transparently support Python and Java packages. And next one, we are also working on some software porting tool. It helps us to analyze the source packaging and to find out which part is needed to change for architecture dependent, and suggest some modifications. This will greatly speed up the porting of all small packages. And we are trying to be more and more open. We have an open textbook based on LoongArch, and we have open SoC chip design for LoongArch. We upstream most software works. And last, I will briefly talk about lessons we learned. The first one is that the API design should be given enough priority. Just now I talked that internally we went through the one major rebuild. Let's build every package from start. Then just after less than 2 years, we have to upgrade to a new version of the API because some, for example, to some relocation efficiency problem and some file standard problem. So this change is very difficult to keep compatible with current products. So it has been a headache of today's commercials. I think this is a very big lesson we learned. And the next lesson is that I think we could be more open. Overall, for the previous works, it somehow took the Android way. That means that we design everything in-house, then open the results, but not the whole process is opened. So API design is a very good example because the API is totally designed in-house, but API related to many components. We cannot, we have no enough experience for every software. So it lead to several tons of upgrade. And up to now, we have enough external contributors now. Most of the work is done by LoongArch itself. So I think that it could be contributed to not open enough, but things are getting better and better. So the first one, the ISA will be fully open soon, and more ecosystem work is now happening in the upstream community. So I have a short summary. The top is try to share the experience that how hard is it to build a new desktop server ecosystem? How hard is to bring out a new ISA? The answer from our experience that with the help of the current open source world, a mature ecosystem has been built in less than 4 years. This is unbelievable for many experts, even now. But it comes not without any preconditions, because the Longshan team has worked on processors for more than 20 years. They have gained many experience or many core components. For example, compilers and all kinds of big ones for like browsers. Because they have experience in almost all major software, so the things can be done in relatively short period. So we talk about the first stage, and we talk about some measures to accelerate the process, and we also share some lessons learned. Finally, for me, it's a very exciting experience to see a new ecosystem built for a new instruction set. I hope more people can join us. We have fun. We can have fun together. That's all. Thank you. Any questions?